I'm going to explain a couple of basic medication dosage calculations. These calculations are important for nursing students because they need them to pass NCLEX, and also they just plain old need them to function as a nurse. I'm going to start out with the most basic and probably the most useful drug calculation formula. And this is the desired dose over dose on hand formula. And it is desired dose over dose on hand times the volume. Let's say you are to administer 3 milligrams of diazepam. On hand, you have a bottle, and it reads diazepam 2 milligrams per tablet. So in this case, your desired dose is 3 milligrams. That's the amount you want to give. The dose on hand is 2 milligrams because in the bottle you have tablets and each tablet is 2 milligrams. So you want to say desired dose 3 milligrams over dose on hand 2 milligrams. So that is 3 divided by 2 times the volume is 1 tablet. So that isn't going to change your answer here. So you just need to go 3 divided by 2. If you do that on your calculator, you should get 1.5. So 1.5 tablets, right? So 3 divided by 2 equals 1.5 times the volume, which is 1 tablet. So it is 1.5 tablet. So now let's do a liquid, figure out how much liquid to give. Now with the tablet, when we figured it out, it was, there's the desired dose, or the dose on hand was 2 milligrams per 1 tablet. And that's how it usually is when you're working with a tablet. But the dose on hand for liquid doesn't always turn out to be per 1 ml. So this is where we're going to use that, multiplying by the volume. For example, if it says that there's 325 milligrams in 5 milliliters, then when we were done figuring out, you'd multiply it by the 5. So let's do a problem here. A child that weighs 32 pounds has been diagnosed with influenza B. The child's vital signs are as follows: temperature 101.6, pulse 124, respirations 24, blood pressure 122/78. Your orders read to administer ibuprofen 5 milligrams per kilogram of body weight as needed for a temperature of from 100 to 102 degrees Fahrenheit. You are to administer 10 milligrams per kilogram of body weight if the temperature is greater than 102 degrees Fahrenheit. So first of all, let's see how many milligrams we'll have to give this child. We know that we're going to end up needing to know how many milliliters, but we need to know the milligrams first. And the milligrams that we're to give for the temperature of 101.8 will be 5 milligrams per kilogram. So you see that up there in the order there. It is for a temperature between 100 and 102, give 5 milligrams per kilogram. So how many kilograms does the child weigh? Let's see. Well, we don't have it in kilograms, do we? We've got up there that the child weighs 32 pounds. That's not going to do us any good. We need the child's weight in kilograms. So we're going to have to convert these pounds over to kilograms. Well, every pound is equal to 2.2 kilograms. So we need to take the pounds and divide it by 2.2. Well, he weighs 32 pounds, so 32 divided by 2.2 equals 14.54 kilograms. If we round this to the nearest tenth, it'd be 14.5. So now we know that we need to give 5 milligrams for every kilogram of body weight. Well, the kilograms is 14.5, so we have to say 14.5 times 5, and that equals 72.5 milligrams. That's how many milligrams we're going to want to give. And you plan on administering that 72.5 milligrams from the bottle here. And as you can see, the concentration is 100 milligrams in 1 teaspoon. As a nurse, you will never measure your medication out in teaspoons. 1 teaspoon is equal to 5 mLs. Therefore, we know the bottle is saying that we have 100 milligrams in every 5 milliliters. Now I think we got everything we need here to set this up as a desired dose over dose on hand problem. The bottle says 100 milligrams in 5 mLs. So our desired dose, though, is 72.5 milligrams, right? So desired dose, 72.5. Overdose on hand, which is 100, times the volume, which is 5. So 72.5 divided by 100 equals 0.725 times 5, which is the volume, right? So times 5 is 3.625. Let's round that off to the nearest tenth because our syringes that we administer things with are graduated in every tenth of a ml. So 3.625 will round to 3.6. So to give 3.6 milliliters, you would do that with a syringe, a 5 milliliter syringe. You would measure it in a 5 milliliter syringe. Always try to get the syringe that's closest to the volume you are administering. Now, the other size in that category would be 3. Well, a 3 milliliter syringe is too small, right? So it has to be the closest one that's a little bit bigger. So 5 milliliter syringe is the one that you would use. So in this case, you would not want to use the 10 ml syringe. Now, if that's all you had, you can do pretty accurate with a 10 ml syringe to give 3.6, but that's not your desired syringe. Your desired syringe is a 5 milliliter syringe. And now if you think about it, let's say you had a big 50 milliliter syringe, it would be almost impossible to accurately draw up 3.6 milliliters in a syringe that large. And that's just an example I'm giving to give you an idea of why you want to get as close as you can, because that you will be given the most accurate volume by matching it as close as you can match it. Now when you look at the syringe here, you can see that you've got the little lines there, right, that they're graduated at every tenth. So you go 3 milliliters, and then you can see where the 3.5 is. That's the little bit longer one there, and then one more is 3.6. So that is 3, and 6 of those little lines is 3.6 milliliters. Another thing worth pointing out on these syringes here is you can see that that little black plunger, which is on the end of the syringe there, the part that goes in and out through the syringe, it's not flat. It is kind of cone-shaped. Well, if you look down at the other end of the syringe, it's kind of cone-shaped there too, so it matches that. You line up the edge of that black rim, that edge of that plunger there, the side that's touching the sides of the syringe. That's where you line that up with the 3.6 or whatever your measurement is that you're trying to get. That little edge is what you're trying to line up there. And I think that's probably it. I can't think of any more I need to say about desired dose over dose on hand. It is a handy formula and something that you'd be using a lot as a nurse.